Hi, I'm Kumar and Siva. Thank you so much. It's an honor to be here and to present to you folks. We're going to talk today about scaling enterprise AI. We're going to share with you a lot of what we've learned over the last year and a half that I've been leading the enterprise AI initiatives. And with me, I have Victor. Want to introduce yourself?
Sure. Thank you, guys. I'm Victor. I'm one of the AI solutions architects, so I've worked closely with Kumran to enable a lot of our Fortune 100 customers to deploy their AI workloads on AMD hardware.
Okay, and so together, what we're going to do is we're going to walk through some, actually, get the slides here. First of all, of course, we have to build suspense by showing you our cautionary statement. And then we'll go into a fair bit of detail here in talking through some of the architectures that we have seen from customers, and then also to give you an idea of what AMD is doing in terms of both our technology, our focus on the vLLM router project itself, where Victor is going to walk through some of the architectural details and some of the areas that we have seen are applicable to large enterprise customers. So first off, I want to just give like a really high-level view of kind of the architecture's deployment models that we're actually seeing, because it's actually very, very relevant to the way that enterprise leaders, IT leaders, are thinking about deployment. And starting with the very largest enterprises, but now really trickling down to even folks that are sort of mid-market that don't necessarily have the same large footprint and installation base. So we'll go through the approaches to adoption. We will talk through some of what I call the enterprise AI runtime, routing policy, the vLLM Semantic Router, and then through things that we do at AMD. So first off, if you look at where people are today and the way that folks are approaching enterprise AI, it is very much built around a siloed type of approach where you have completely different models, different infrastructures for different use cases. So for example, if you're running coding today, you may be using Claude. If you're using knowledge management, you might be using a completely separate package that's deployed on-prem. You might have another package, say a Copilot-based package for automation for agents. So you have all these silos that are building up. One of the key concerns when you talk to enterprise leaders, CIOs, is the level of control, right? And it's the level of where does the information reside? Where does the enterprise context ultimately reside? And so when we think about this, the advantages here, though, is it's the easy button. It's easy to deploy. It's also easy to it's also performant because typically you'll have, for example, for coding, you could have the best possible model targeted for that particular use. The alternative, and this is kind of what's emerging with a lot of the enterprise leadership we talk to, including folks, our leadership at AMD in our IT department, we're looking at kind of going to this model where you have users for different classes of use cases and different users at the top, a stateful enterprise runtime that's in the middle that captures context. It captures how tools are used. It also captures kind of the skills, the context history, evaluations, and audit to create reproducibility, and most importantly, in the context of intelligent routing, to be able to capture kind of the workflows and workflow validation that is required to run intelligent routing appropriately with determinism and non-determinism. We'll talk a little bit about that. Underlying this, you have the model layer, which is very much targeted at the endpoints. But the thinking here is that the context all belongs in the runtime, that the model is now disaggregated. So it's just endpoints. And you can replace that with on-prem open weights. You can use frontier models. You can use different types of models there. A tuning factory for tuning specific data that you've gotten into an SLM for efficiency purposes. And then there's two types of data stores that are emerging. And what we've done at AMD, we have systems of record, which are typically our Oracle databases, I won't say legacy, but they're traditional IT implements, and that forms our systems of record. We have now a new data backbone that's built around graph. Puppy Graph is our implementation, as well as sort of metadata pointers. And so we have a store, a object store that actually has pointers back into system of record, as well as maintaining these contexts and these histories as sort of first-class objects. So double-clicking a little bit into the actual runtime itself, with the tool calling, key issue that almost everyone is dealing with today is the MCP context bloat. When you do tool calls, you get back very large, because it's not designed to be compressed into a context. It comes back to you with the full output. Skills and context history, of course, skills are a primary way for enterprises to put in kind of the evolution of their practices. Right, so what you had in traditional IT as runbooks, you can now evolve those into skills. Permissions and orchestration, access control, of course, is very important. And then evaluations and audit, I think, really start to go along with the model router, because what that allows you to do, and we'll talk about that, is being able to be able to select which way you go. The model router we'll talk about in quite a bit of detail, but that's really the kind of the key piece that allows the separation of the model from the enterprise runtime. Okay, so having talked to that, let's take a look at an example where we have a routing a routing policy. So this is the enterprise runtime talking to the intelligent model router in that prior diagram. So what you have here really are two classes of flows. You have known workflows, and then you have unknown workflows, unknown requests coming through. The intelligent model router is actually very flexible. It's designed for both use cases. Victor will go into the detail of how that works, but setting it up, on the known workflow side, what you want to be able to do is take skills, logs, and your evaluation sets, come up with validation data that then turns into hints that allow the model router to choose different between the different endpoints. So, for example, if you know that a workflow needs to have a certain level of intelligence, you're able to route it to that particular type of endpoint model. The goal here is to make sure that the outcomes don't change. Right, so the known workflow side on the left is allowing the intelligent model router to choose models without changing the outcomes themselves. What this also forms over time is a set of validation data that can also then be turned around and used to fine-tune SLMs. And so when you do that, you're able to then draw even more efficiency by taking the knowledge, the understanding, the validation from the workflow, and putting it directly into the model, and therefore making it more efficient. So you look at the intelligent model router. You have frontier, you have LLMs, you have standard LLMs, you have fine-tuned, and then with that you get into the kind of model choices you can make. So a couple of things to point out here, and things that we've been working with here at AMD. So the intelligent model model router can route to frontier models. It can route to large open weights models that can be either in the cloud or on-prem. It can also route to smaller models that are, for example, be able to fit perfectly on-prem with our PCIe cards, the MI350P. And then it can also go to fine-tune models. So a couple examples here of why you choose different models. So for example, for coding, you guys have all seen, I guess, Kimi K3 just announced, and they show all these very competitive data points. If you don't need the kind of extreme intelligence, then you are able to fall back onto some of these open weights models, and they work well enough for lots of use cases, right? So that's kind of coding tuned is very common, and that shows you a good benchmark comparing open weights to frontier. The other side of it is where you've been able to take data and do that fine tuning. So I talked about having those validation flows and then being able to use that on an SLM. One really good example of how this has turned into a really practical SLM is the open telco model that AT&T, in conjunction with AMD, developed, and we actually announced at MWC. What we showed there is taking 1 million question-answer pairs and fine-tuning a model. We were able to get frontier class performance, right, with a model that was 8 billion parameters large. So easily fits into our PCIe cards, but provides you with performance that's superior to, let's say, a Gemini or an OpenAI model that's much larger with much larger context. So significant cost savings and also latency advantages. All right, so with that, I'll turn it over to Victor to walk you through this vLLM Semantic Router project. So looking at the intelligent model router here, this is a project that AMD is very much invested in. So I want Victor, if you want to take this and walk us through some of the details here.
Perfect, thank you. How many of you guys have heard of the vLLM Semantic Router? Raise your hands. Okay, a few of you. The rest of you are going to learn some things. So the vLLM Semantic Router project has this intent of answering the question of, if I have a query, what model should I send that query to? And the vLLM Semantic Router does that with a few steps in its pipeline. So it does signal extraction. So signal extraction has a way of describing that query, understanding that query, and composing a signal vector. And then that signal vector will go through a Boolean decision engine. So the Boolean decision engine basically takes a set of rules that users can provide to determine how to route the queries. And then downstream, you have plugin chains. And then plugin chains allow you to basically enrich the queries, right? You have here on the presentation examples of a semantic cache, PI filter, agent memory. So that's what the decision chain looks like. And then at the end, you have different tier model endpoints that can be utilized. And so organizations have, heterogeneous model fleets. So these heterogeneous model fleets might live in the cloud. They might live on-prem. They might be specialized fine-tuned models for specific enterprise. And the vLLM Semantic Router basically allows you to route queries to all these different kinds of models in the cloud, on-premise. One of the customers that I worked with, that was exactly the critical, almost low-hanging fruit, right? To find a way to offload a lot of cloud frontier model calls to an on-premise architecture, in this case, AMD hardware. So the vLLM pipeline starts with signal extraction. So signal extraction basically consists of 2 tiers of signal extraction methodologies. You have heuristics, and heuristics are really fast. You can think of things like keyword search, things like language detection, context length detection. They take less than a millisecond. But you also have learned signal extractions. Think of putting the query in an embedding space, using something like cosine similarity to compare that query to other similar queries. And then the router also has domain-specific classifiers using the MMLU categories to determine what domain the query might fall into. Same thing with jailbreak intent, or if there's any PII in the query. And 2 things to point out here is that, number one, the signal extraction basically is as slow as your slowest signal extractor, because everything runs in parallel. That's number 2. So with everything running in parallel, you have the ability to use all of these at once, right? But with that said, you don't have to. Down the line, if your Boolean decision engine is using different signal extraction methods, not all the ones listed here, you won't spend compute cycles on them, right? So speaking of the Boolean decision engine, once you have the signal vector that is extracted by using these heuristic and learned signal extraction methods, you then have a domain-specific language. And it reads a lot like English. And the semantic router allows you to explain these routing rules using and, or, and not functional expressions. So the key point there is that with and, or, and not, you have a functionally complete configuration. And then the domain-specific language basically takes the and, or, not expressions, because they're functionally complete, and puts them into a custom Kubernetes resource. So now you have configurations that are auditable, they're version controlled, so you have a very clear path or way of understanding why a certain query was sent to a specific model downstream. And the decision engine is actually really fast. It's less than the 10th of a millisecond, something like that. Most of your latency you'll actually be seeing upstream in the signal extraction component of this. So with the Boolean decision engine, right, excuse me, with the Boolean decision engine, you have a functionally complete, capable set of rules to determine, using the signals that you have, where to route them. Now, with a plugin chain, you have a lot of other extra features now that you have a way of determining what kind of signals or the composition of the queries. You have a way of deciding what plugin caches you can integrate. So there's a couple of examples of that here. There's the semantic cache, right? So once you figure out that a query is going to go to a specific model, maybe you put a semantic cache in front of it. And what that does, basically it says, okay, if this query looks similar to a query I've seen before, in my cache, we get a cache hit, and you might not even route to a model. You just return what was in the cache. So it's zero latency cost, zero model inference cost. Another example of plugin chains is PII filtering, right? So you might have a domain classified in your signal extraction for medical information, but it might include a specific type of PII, and you're okay with that. Or if it doesn't, then you completely block it, right? The plugin chains are very, again, plugins. Another one is agent memory, very similar to semantic cache. If you have a lot of rounds of an agent on a previous query, you don't want to repeat those rounds of agent calls, and you can have some similarity with this query and a previous query to augment this query with agent memory, so reducing downstream rounds of agent work for this query in this example. And we have a lot of other examples not shown here, but you have something like downstream system prompt augmentation. So maybe a specific type of query that has a type of domain with a certain complexity might have some system prompt enrichment, or another type of a query might have a RAG augmentation, right? And then, of course, you can build your own. And then even upstream, you can build your own signal extractors. All these signal extractors work on small embedding models that, at the moment, run on CPU. And all these learned models we show here are actually running on the same embedding model. They're all just different LoRa adapters. So with some of our customers, they might take the PII classifier and fine-tune it with more PII examples that they have from their enterprise data. Okay.
All right, no, thank you. Thanks for that.
You got it,
Victor. So, so going back here, so we think about the endpoints that the model router, the semantic router actually can target. We also have, I guess, in the interest of showing you where AMD comes in here, we have this huge a variety of modalities that we deploy with, that we've enabled, right? Going all the way from PCIe, we have PCIe cards that can run in workstations, but all the way up to the frontier models, the frontier cloud providers themselves. In the case of this particular semantic router, you are able to literally target models that are on-prem on your PCIe card, small, medium models, the fine-tuned models that I talked about, potentially running in those PCIe cards. We have, of course, our 8-way or MI350s that allow you to run more complex models. So, for example, the 2.8 trillion Kimi K3 that just was released, that would run very easily on our MI350s because it has enough capabilities. And then, of course, we have, with a combination of our servers, be able to do the RAG tier that we talked about for some of the appliances and the sort of siloed use cases in the front. And of course, our Helios, which you can see in our demo area, is being adopted by a number of the frontier labs. I wanted to kind of bring this back also to tell you a little bit about what we are doing as AMD IT. We are doing this own runtime where we are implementing the model router, and we're using that especially for our agents that run within AMD. So, for example, we have an InfoSec agent. There's actually a session running right now in parallel where Rekha from our IT department is actually talking through some of those use cases. But so we have that as a deployment model. We are also doing siloed deployments. So, for example, for coding, we have an appliance that we've developed that actually has a leading edge model. We have a software stack that from a company called SpectraCloud that we'll talk about later as we take this product maybe more to market. But that allows you to do kind of an appliance type of use case, sort of being able to drop it in, have its own pane of glass, but have it kind of cradle to grave managed. The other type of deployment, which we have as a deployment pattern, really is leveraging frontier harnesses and driving local agents running on local machines. So having a frontier model that is able to understand what goes on locally and is advertised as skills. And so you're able to take almost the best of both worlds in some sense. You're able to control the context for the local models, but you're able to also leverage kind of the speed of deployment and understanding from the cloud as well. Okay, so one important thing too is we see appliances addressing kind of immediate pain points from a go-to-market and market standpoint. So one of the things we've been working on is building an appliance approach, building a solution set, again, going back to the model router, allowing you to have solutions that can solve specific problems with specific models, being able to go into the cloud or also potentially on-prem. The keys here, we have a full stack. We call it metal to model experience, full lifecycle management, and with targeted hardware. We'll show you a little bit of the software stack here, but it's of course built out with some of our work with some of our partners. Some of the defined use cases that we're currently using internally, of course, coding. We do have a appliance now we built around for threat detection and digital coworkers. So this is implementation of a enterprise claw with a local agent running in our platform. So let's talk a little bit about the different packages now that we have for open source support and open source packaging. So we now, if you can think about AMD, we have a complete software stack. Going from hardware all the way up to agents. Now, this is a combination of us and partners that build this out. But the key pieces that AMD provide, starting with the very bottom, we have the AMD GPU operator, which has Kubernetes support for all the major distributions. Going into the semantic router work, we are going to be doubling down and doing a lot of work with semantic routing. We're also going to work with some of the other pieces in that enterprise runtime. So doing things for observability, doing things for permissions, the evaluations, and the context history. All of those pieces we've been working with partners and/or open source packages to try and enable a complete solution. On the other side, we will have also the implementation for an appliance. On the AI inference side, we have really a key investment in our AMD Inference microservices. These are containers that actually contain popular models, optimized for OSL, ISL, different characteristics that you care about in deployment, put all together into a single container with packaged up with the vLLM engine itself, as well as the configuration altogether, allowing a sort of an easy button for enterprise. And we share that it's open source, so folks can even pull models down and just take the information from the profile and do it together, or they can just use the AMD inference model itself. On top of that, we also have a ecosystem of blueprints we've built out. And so these are reference implementations that folks can use for specific use cases. All right, so with that, we're going to just, I'll summarize here in kind of what our overall strategy and thinking is. So I think the enterprise AI strategy will ultimately shape business outcomes. You know, going back to what we started off talking about, it's super, super important that you decide on a deliberate strategy of how you want to go. If you have enterprise ambitions to actually build out a runtime, you need to look at kind of those different pieces. The semantic router is a very important piece of it. Every enterprise, I believe, will have a split between what they do centralized and what they do in silos, and you need to sort of do that deliberately. And then understand what moves into a provider and what you sort of do on your own. From an AMD standpoint, we're building out the software infrastructure, the hardware infrastructure, and then we're investing in all the different components needed to drive both the centralized implementations as well as the siloed type of appliance type of implementations. The semantic router, of course, is a key piece of that, and we will be doubling down on doing that.